As many of you are aware, we're currently running a consultation to find out views to help us set an interim target for emissions reduction by 2030. And this will help us, this will ensure that we are on track to achieve net zero by 2050. We felt that it was important for members of the public to understand some of the key areas for emissions reduction by 2030, and that's why we're running this particular webinar on renewable heating. And this evening, this presentation will be presented by representatives from Gemserv, a low carbon specialist consultancy. We have three presenters who are Rob Hanneman, Head of Analysis. Rob has nearly a decade of experience working on the decarbonisation agenda, and in particular on decarbonisation of buildings, and he has led the development of this particular report. We also have with us Christopher Lewis, economic analyst. Chris works to develop the detailed economic modelling to underpin the shift to low carbon technologies and led on the district heating element of the report. Last but certainly not least, Rory Matthews, and Rory is a senior economic analyst, and he's been working with Gemserv for nearly 4 years with a particular specialism in decarbonisation of heat, and he developed a residential building stock analysis in this report. And with that, ladies and gentlemen, I will pass you to Rob to start the presentation. Rob.
Thanks, Rose. Thanks for the introduction. It's really nice. Great. Well, it's a real pleasure to be talking to you this evening. As Rose alluded to, we've got a sort of a 20-30 minute presentation. We're going to go through the renewable heat scenarios that we've been developing over the last 9 to 10 months, and then we're really happy to respond to any questions that you have and just have a bit of a conversation around the findings of the report. Brilliant. Without further ado, I'm just going to get up our presentation. Good stuff. Great. So I think the first thing that I'd like to kick off with saying is that this project's been an absolutely fantastic one to work on over the past 10 months or so. We've brought over 10 different analysts and consultants from Gemserv to work on this project, and we all have sort of our different areas of expertise and specialisms that we've brought to this project. So tonight it's myself, Rory, who's led the archetype modelling and is absolutely a heat pump expert. So any heat pump questions, I think he's the man to ask. And Chris, who led the heat network analysis and the development of the infographic and report. So pleased to be speaking to you this evening. Great. So we want to do really sort of 4 things with the sort of 20-30 minutes that we have to present. I'm going to kick off with just a bit of a background to the project and a background to Gemserv so that you know who we are. I'm then going to hand over to Chris, who's going to give you the current situation in terms of heating on the island and why this transition matters. Rory's then going to talk about some of the key findings that we have from the report and some of the key technologies that we've highlighted as being really important for the transition. And then I've got one slide at the end, just some thoughts on kind of next steps and how you can get involved with low carbon heating. Brilliant. Okay, so first of all, just to introduce sort of today's topic. Today we're going to be talking about how the Isle of Man can transition away from fossil fuel powered heating to low carbon and renewable technologies. So move away from a dependence on natural gas and heating oil primarily towards some of the low carbon technologies that Rory will be introducing later. And over the past 9 to 10 months, we've been doing a lot of in-depth analysis as part of our scenario report, looking at the best solutions and the trade-offs between those solutions as well, with the ultimate 2050 target in mind. Great. So just to give you sort of a 2-minute introduction to Gemserv. So this is essentially what our business unit, our low carbon business unit within Gemserv does. We've been a company since 2002. We work primarily in the UK, but we also have an office in the islands, and we are really energy experts and low carbon experts. I've really enjoyed working on this project because it has allowed I've got the experience of working with lots of different specialists from across the business. So we brought heat pump specialists to this project, heat networks, hydrogen specialists, biofuel specialists, and energy efficiency experts as well to advise on this project. Great. In terms of some of the things that we get involved with, we work with the UK government on a number of different programs, including the Heat Networks Investment Programme, which is the way that the UK government funds heat networks currently. We've also been involved with the Biomass Suppliers List as well, which is a sustainability programme in the UK. We also work with a lot of low carbon industry associations, so a couple to highlight that are relevant to today's discussion. The HPA in the middle there, that's a heat pump association in the UK, so we work with a lot of the heat pump manufacturers, and Rory actually has a lot of that experience. We also work with the National Insulation Association, so one of the technologies that's going to be really important to decarbonising buildings is energy efficiency and fabric efficiency. So that's things like loft insulation, solid wall insulation. And again, we work with some of the manufacturers in the UK on energy policy. And finally, we work with a lot of private sector clients as well in this space. So to highlight two that I think are quite relevant, you've got NEBI there. They're a heat pump manufacturer. And we work with them in the UK, and also Baxi is a heating system manufacturer as well. Great. So just to give you an overview of the report that we've been developing, it has a number of different features that I'd highlight. The report provides a number of technology and low carbon insights. So it has key considerations for important renewable heating technologies, and it dispels some misinformation around some of those solutions as well. There's dedicated analysis on really interesting questions about whether or not hydrogen is viable and a cost-effective solution for heating on the islands, and also a first bit of analysis as to whether or not heat networks are a cost-effective and viable solution for the Isle of Man. We'll talk about heat networks sort of later on in the presentation. Hydrogen was analysed as being too costly for heating on the island, and we went through a very long and comprehensive process to develop that conclusion. We developed some policy recommendations as well, some pragmatic policy recommendations based on our experience, but also based on the interactions with the Isle of Man policy team. And finally, something that I'm about to sort of introduce, we've developed an in-depth analysis of the Isle of Man building stock. So we've looked at the different types of buildings on the island, and we've considered which low carbon heating solutions might be best placed to decarbonize those buildings. So how have we gone about doing that? So I'll give a brief overview of the approach that we've taken to that residential building modelling. So what we've done is we've taken some data from the Isle of Man, which provides information as to property characteristics, so property size, property age, also the types of heating systems that are in different homes across the island. And we developed 72 different property archetypes, which we think are pretty representative of the building stock on the Isle of Man. We've then taken some energy price information as well from the Isle of Man, so fuel prices like natural gas prices, heating oil prices, and we've also taken some data on some of the development fuels, some of the biofuels, and we've taken the prices of those fuels as well to consider the sort of the costs and benefits of the transition. And finally, we've taken some technology cost estimates as well, so the costs of some of these new renewable heating solutions. And we've used a lot of GB data that we have, market data, which we've used to essentially estimate the cost effectiveness of different low carbon heating solutions for those 72 property archetypes. So the key outputs are a least cost solution for each of the property archetypes. So what is the lowest cost technology available? We've estimated carbon emissions, upfront costs and running costs, so fuel bills and the capital expenditure needed to move from one system to another. And we've used some heat pump modeling as well to estimate the efficiency of some of these new low carbon heating solutions. Brilliant. So final slide from me. There's a lot of detail in the report, and I'd encourage you, if you're interested, to go and kind of read it in more detail. I'd flag that we've developed 3 different scenarios. I think this reflects the fact that there's a little bit of uncertainty about the different pathways that can be taken to achieve the same goal, which is net zero emissions and zero emission heating. So these 3 scenarios, they vary based on the speed of decarbonisation, so how quickly we get ahead with the transition and move to renewable heat, and also the level of societal change, so whether or not we require households to do a lot of the heavy lifting, or if we think that government can develop some of these solutions and there's less of a role for consumers to invest in energy efficiency, for example. And these 3 scenarios that we developed, called Leading the Way, Consumer Transformation and System Transformation, and they're very similar to the scenarios that have been developed in the Arup report, which was the renewable heat report, the renewable power, report for the Isle of Man, and also the national grid in the UK future energy scenarios. Brilliant. And Rory's going to give some results of those scenarios in terms of some of the key technologies that we're recommending as part of that scenario analysis. Great. So first of all, I'm going to hand over to Chris, who's going to give an introduction to the decarbonisation of heat and why it's really so important. Chris.
Perfect. Thank you, Rob, and thank you, Rose, for the introduction. I suppose everyone here is aware of climate change. It must be a big shock if not. It's definitely been described as the defining issue of our time by the UN, and it was only really in our lifetimes that it went from a very fringe issue to being something that everyone is definitely on board with. Decarbonisation is something that is essential for everyone across the world. For the Isle of Man specifically, climate is having impact on flooding, on heat waves, on rising sea levels, erosion, etc., etc. Lots of incredibly worrying things that have to be nipped in the bud. And ultimately, to get there, all aspects of our lives have to be transformed, and transformed rapidly. And the way in which we heat our homes is no different. But it's not all doom and gloom and scary stories. The transition to net zero ultimately gives us a really unique and fundamental chance to reshape the way and redefine the way in which we live and work, and to take control of various aspects, things like air pollution, health and outcomes, etc. Next slide, please. So heat on the island today. So as mentioned, heat is what we're going to be talking about. Currently, residential emissions, of which heating makes up the majority, account for around 20% of all emissions on the island. So in the greenhouse gas emissions inventory chart below, you can see that as the light green and you can see that only transport and energy supply have a higher share. Next slide, please. Cool. So in terms of what those heating systems are made up of, as you can see, it's primarily driven by mains gas users and oil users. In fact, the vast majority, overwhelming majority, are on those 2 types. Electricity and LPG also make up a few thousand between them, and there are a few people on smokeless fuel as well. I think the key standout from this graph is just the scale of the challenge. In terms of those technologies that we are going to be recommending, they're not on the board yet, and transitioning into those being the primary driver of heat across the island is going to be really difficult, and that's the main challenge for us. Next slide, please. So as mentioned, the difficulty is it's not only hugely important, but it's also incredibly difficult to do. So in order to reach net zero, 26 households are going to have to be swapped to clean heat sources each week every week for the next 28 years, starting today, which is a huge challenge, particularly when we consider the lack of natural acceleration within that changeover. And this is something that's been recognised by the Isle of Man, and hence why we're here in front of you today. In 2019, a climate emergency was declared, and then the Climate Change Act was brought into law in December, committing the island to making considerable progress and setting out all kinds of action plans and generally getting forward on the issue. I think next slide. I think that's it for me. I'll hand over to Rory.
Great, thanks, Chris. So, yeah, I'm going to be talking a bit about the different low carbon heating solutions that have come up from that archetype analysis that Rob went through earlier. So on the screen at the moment, you can see the outside unit of an air source heat pump, which is one of the main technologies that has been highlighted as being a cost-effective option for decarbonising heat on the island. Rosie, if you can go to the next slide, please. So I'm going to start off by talking about heat pumps. There's another two technologies that I'm going to focus on, which are heat networks and hybrid systems. And I'm going to run through sort of the key things to know about each of them, the types of emission savings that you can sort of expect to see from those different systems, and then the rough numbers that we're seeing from our different scenarios coming up for the transition to each of these different technologies. So forgive me if you already know about these technologies. I just wanted to make sure that some of these sort of fundamentals were covered, I guess, and hopefully give an introduction to some of you that may not have heard about them before. So starting off with heat pumps then. So heat pumps are powered by electricity in general, and they provide heat to your home in exactly the same way as a boiler would do through a wet system, so providing heat through your radiators. It's a bit different in sort of the back end in the way that that heat is produced, which means that you actually have to have a bit more space taken up compared to boilers for heat pumps. For example, hot water cylinders are required to be put in alongside the heat pump, whereas with some boilers, for combination boilers, you don't need that. And the big thing at the moment with heat pumps is that they do cost a lot to install, considerably more upfront than the sort of more traditional heating systems. But the technology is already widely available, so there's no waiting around for this technology to develop further. It can be deployed now, and it can be deployed widely to really crunch down and reduce emissions compared to the current heating systems. Sort of, I guess, those disadvantages sort of being taken into consideration too. And in many countries, they're actually already the predominant heating type. So, for example, Germany last year deployed more heat pumps than any other heating system. They've been in use in Sweden since the 1970s and are now the predominant heating technology that's used in homes. And I guess while those sort of countries and economies have got different scenarios and situations that have driven them to that, it proves that the technology works and is available to be deployed already in lots of different scenarios and weather conditions. And what this means is really that heat pumps create considerable emission savings compared to the fossil fuel heating systems. So there's a graph at the bottom there which shows that compared to a gas boiler currently, you're saving over 20% on your emissions on the island, and compared to a gas boiler, just under half of the emissions compared to what you would be using. Now, that's right now. So if you deployed a heat pump right now, you'd already be saving that much. The key thing, though, is that we're assuming and we're expecting renewable electricity generation to keep growing. So the electricity grid is only going to get cleaner and cleaner and cleaner, and heat pumps will only make sort of the most of that. And it means that by 2040 on the Isle of Man, you can see how low the emissions are expected to be from air source heat pumps and ground source heat pumps. Sorry, that's what ASHP and GSHP stands for, which almost eliminates the emissions coming from those heating systems. And this means really that it plays a large role in the scenarios that we've created for this analysis. So we see between 6,700 and 20,500 households switching cost effectively to low carbon heating out of the low carbon heating systems that are available. So that's a considerable chunk, and we think that they are a main solution and absolutely required if the island is going to decarbonise heating based on the current solutions available. Rose, if you go to the next slide, please. So the second solution that I'm going to talk about is heat networks, and you can see some of the piping that is associated with heat networks on the screen currently. So if you just go to the next slide, please. So the sort of key thing to know about a heat network is that it's actually a piece of infrastructure. It's not a low carbon heating solution in itself, but it's more of a distribution system that makes the most of a centralized source of heat generation or waste heat to work efficiently to deliver heat from that centralized source to a number of different buildings or to different households. And while this sort of creation of infrastructure requires considerable planning and infrastructure investment up front, it can lead to really substantially lower running costs, even compared to fossil fuels currently. Now, the other advantage of heat networks is that they're not reliant on one technology. Heat networks can be powered by many different technologies. So there's a big move in what's called fourth generation heat networks currently to heat pumps as the main source of heat to be provided through the heat networks, but you could also complement that with gas boilers, micro CHP, ground source heat pumps, direct electric. Any sort of heating source can be fed into the heat network, and it can also make the most of the waste heat that's ejected from commercial premises such as data centers, so that doesn't just get wasted. So what we see on the Isle of Man in our scenarios, and this is I'd like to emphasize a sort of desk-based research project that we've conducted here, is the potential for between 2,000 up to just over 10,000 households to be able to switch to heat networks. Now that's definitely subject to boots on the ground and I guess an engineering assessment too, but this is sort of a high level potential for the number of homes that might be able to transition to low carbon heating through this route. Next slide, please. So the final solution that I wanted to run through was hybrid heat pumps. So this is a combination of heat pumps operating alongside a backup heating system, which is traditionally a boiler. So this solution would see a heat pump running maybe around 80% of the time, or meeting 80% of the heat load of a property. But then at the same time, the system has got an integrated boiler in place, which can provide around 20% of the heat. So that can be done to sort of provide peace of mind for those of you that might like your boilers and might not want to just switch straight to a heat pump. It can also help reduce running costs. So particularly meeting the heat demand at peak times or the coldest times, having a backup boiler can help with overall system efficiencies. And I think that sort of another key point to emphasize from the household perspective is that this can lower costs and disruption. So often with heat pumps, you might need to install a few larger radiators, which could require considerable disruption. If you have a hybrid heat pump, though, that necessity can be overlooked, and you can just continue to operate with the current radiators that you might have in place. Now, the one thing I really want to emphasize with this solution, and this was a really sort of key finding from our report, is that in order to align with net zero and decarbonising heating fully on the island, there would need to be the development of biofuel, which is a low carbon alternative to LPG, for example, to really reduce emissions alongside the heat pump with the backup boiler part of the system. But there's a reliance on these being developed, so they're still not commercially available at scale, unlike heat pumps, and it might mean that there's a risk that these don't develop. And if you're sort of paired with a fossil fuel boiler and you haven't been able to transition over to biofuels, then it doesn't actually offer a long-term solution. So that development of the biofuels is really key if hybrids are going to be part of the solution, to sort of consider going ahead. So in our scenarios, you might see at the bottom there that we are estimating between 0 to 17,600 households. So the 0 scenario is our system transformation scenario, our consumer transformation scenario, which assumes that only technologies that are currently developed are deployed. And so we remove the reliance and the risk associated with biofuel for that scenario, which means that hybrids aren't a viable option for decarbonisation. But in our system transformation scenario, what we see is a big prevalence of biofuel development. We assume investments poured into the sector to help that grow, and maybe up to 17,600 households in that scenario could transition to a hybrid heat pump solution. That's everything from me. I think I'm just going to pass back over to Rob for one final slide.
Great, thanks, Rory. Great. So final slide. This is a sort of initial thoughts, and perhaps this group is already very well versed on some of these technologies and already thought about how they can get involved with the heat decarbonisation transition. But these are some, I guess, personal thoughts on how citizens can get involved with the transition already today. So first off, some sort of what I would see as sort of no regrets actions that households can take. First of which is to undertake an energy audit. So this would provide information as to the types of measures that could be installed in a house to improve energy efficiency and to lower emissions as well. And I think an energy audit would also help inform a household as to whether or not investing in energy efficiency upgrades is going to be a good thing for the household to do, whether it can save energy, but also save money and reduce carbon emissions. As I think I mentioned previously, briefly, energy efficiency, we actually did a lot of energy efficiency modeling as part of this project. And we think that it plays a really important role in the heat decarbonisation transition. It immediately lowers energy consumption and reduces emissions, but it also helps prepare the house for a transition to a low carbon heating system. So there are certain technologies like heat pumps that operate really efficiently, particularly in a well insulated property. So this could be a really good thing to look into. And the types of measures that we've been thinking about as part of this project include loft insulation, draft proofing, solid wall insulation, these types of measures. Then I think there's some things that if you wanted to go further and you wanted to sort of invest more quickly in low carbon heating, you could go ahead and ensure that your house is renewables ready, so you could upgrade your heating system. And by heating system, I don't just mean the heat source, the boiler or the heat pump, but I mean the whole heating system, including heat emitters and radiators. As Rory said previously, when he was introducing the heat pump technology, heat pumps are really energy efficient, and they're energy efficient because they operate at low flow temperatures. And one of the best ways you can achieve really high efficiency for heat pumps is to have larger radiators, such as underfloor heating, which provide immediate cost savings and also emission savings, and they get your house renewables ready so that you can install a highly efficient heat pump in the future. Of course, you could also invest in a low carbon heating system today. So as Rory introduced, many of these technologies are actually already on the market, and there are a lot of countries across Europe where technologies such as heat pumps are already the dominant heating technology. Rory introduced hybrids as well. There's also solar thermal, which we haven't mentioned today, but might be interesting to some of you, and biomass and biofuel heating systems. And I would signpost you to the Green Living Grant which can already provide some financial support to help with that upfront cost. Yeah, absolutely. So that's £6,000, up to £6,000, 50% funding for some of those low carbon heating systems. Great, fantastic. That's our presentation. I've seen that we've already got some sort of questions coming through. I'll hand back over to Rose at this point.
Thank you, Rob, and thank you, Chris and Rory, for that very informative presentation. We'll now do the Q&A session.